Greetings! This is a video on section 7.3 practice problem number 11. Determine the following for the function g of x is equal to logarithm base 2 of x. Okay, so function features. They want to know the domain, the range, the horizontal intercept, the vertical intercept, the vertical asymptote, and they want it all chocolate wrapped. Okay, so how are we going to do this? Well, probably not a bad idea to go back and take a look at this function on our calculator. We did that in problem 8. So just a quick review. To be able to look at that on our calculator, we're going to have to use the change of base formula. So that would be logarithm base x divided by logarithm base 2. Okay, so that is the equivalent expression to logarithm base 2 of x. All right, so if we do a zoom and a standard here, take a look at that graph. Couple things we need to recognize on this graph. First of all, the y-axis is playing the starring role of a vertical asymptote. This graph comes up and gets as close as you ever want it to get to the y-axis, but it does not touch it. Do not be deceived, because the graph seems to stop right here, into thinking that that is the end of the function with respect to its range. I'm talking about the range for the moment. It keeps on going, okay? And similarly, since the y-axis is playing starring role of a vertical asymptote, we know that the domain starts on the y-axis and then heads out over that away, okay, and out to positive infinity, but it never includes that endpoint. In other words, it never gets to 0. Okay, so what that means is the domain of this function is going to be from 0 to positive infinity, okay? And so I always wondered about this silly table. I think they just kind of wasted a bunch of space here. I guess our answer has to go over here, even though they left us plenty of room to work over there. I mean, you could come over here, I guess, and just shows the beautiful graph that we just saw on the calculator, right? To help us understand the domain, and so that we know the domain starts here with an open dot and blast out to positive infinity on the x-axis, okay? All right, what about the range? Well, let's look at our same really cool graph right here. If we look at the range, what we notice is the range starts down here at negative infinity and just keeps on going and goes all the way up to positive infinity. So the range is going to go from negative infinity to positive infinity. Okay, horizontal intercept. In other words, where does it cross on the x-axis, our horizontal intercept? Well, notice that the ordered pair on the x-intercept right there is going to be at what? 1, 0. And another way of thinking about that is that a horizontal intercept is where we have 0 is equal to logarithm base 2 of x, okay? So what does that mean? Well, if you take and rewrite that out of a logarithm and into an exponential notation, that says the exponent on a 2 that gets me x is equal to 0. Or what? 2 to the 0 is equal to x, which infers to us that what? X is equal to 1. All right, more about that in upcoming funness. You can think about it right now as like this gift from heaven, the 1, 0 thing from the graph, okay? All right, vertical asymptote. All right, so that they're going to want us to give the equation of the vertical asymptote. So the equation of the y-axis is that x equals to 0. The vertical intercept, in other words, where does it cross the y-axis? It don't. The y-axis is a vertical asymptote. We just said that. So what that means is that there is no vertical intercept to it. You don't get to cross vertical asymptotes. Values for x where g of x is increasing. Okay, so let's think of, I'm going to do a fresh copy of the graph down here. So values of x for where g of x is increasing now. So again, our graph looks something like this. So what they're asking us is, where is it moving uphill? So if you were by chance to be standing anywhere on this graph, okay, so here you are standing on the graph, and you kept walking along the graph, notice as you move from the left to the right, you're always going to be going uphill, no matter what x value you pick within the domain. And so what that tells me is the values of x for which g of x's are increasing is the same as the domain of the function, which is from 0 to positive infinity. It's increasing over its entire domain. Okay, values of x for which g of x is greater than 0. Okay, so now g of x greater than 0 means you have to be above the x-axis. So that means it's going to be this part of the graph, the part that's above the x-axis. Well, notice that that happens right here at 1, doesn't it, right? So where the values of x such that g of x is greater than 0, well, that's going to be from 1 out to positive infinity. So it's going to start there, and then everybody out that way is going to work, all right? Okay, so now give me the part of graph here where g of x is less than 0. Well, that means I'm going to be below the x-axis this time. Let's label our axes here, bad form on my part. So if I'm going to be below the x-axis, then what that means is that here's my open dot, and it's going to be what? It's going to be that piece right there, right? Well, notice that that's running from 0 to 1. But the endpoints would not be included, okay? If you feel so inclined, if it feels more warm and fuzzy to you, you can go ahead and use interval notation here, or excuse me, inequality notation. So here, what this is x strictly greater than 0. Not supposed to be an arrowhead there, by the way. Let's make it look like one, all right? Or not, okay? Here, this would be what? X is greater than 1. Here, this would say 0 is less than x, which is less than 1, right? Okay, so the values of x for where g of x is equal to 0, well, there's only one value that makes that true, and that's x equal to 1, all right? Values of x for where g of x is equal to 1, okay? All right, so that says that 1 is equal to logarithm base 2 of x, right? So the exponent on a 2 that gets me x is 1. So 2 to the first power is equal to x, which says that x would be equal to 2. Whew! Lot of stuff going on there, okay? So make sure that all of this makes sense to you. If any of it, any piece of that, or if you need me to explain it better, you let me know, and I'd be happy to do that for you.